Good day, viewers. Welcome to another mathematics presentation. So in this presentation, we are looking at our episode 2, okay, where we are answering mathematics paper 2 for 2023 external candidates. So I did the first part where we answered our question 1. So in this presentation, our focus is on question 2. In a geometric progression, the second term is 21 and the fourth term is 189. Calculate the A first term and the common ratio, which is carrying 3 marks. So we need to first calculate the first term and the common ratio. So let's see how we can answer this question. Alright, so in order for us to answer this question, the information that we have been given is very important. So they are saying the second term is 21. So you write term 2 equal to, because this is a geometric progression, so the formula in finding the terms we use a r power n minus 1. Okay, so this t2 is the value which you have been given, which is a 21. Okay, so here you just say a r. So n is the number of term, which is, they said, second term, so it will be 2 minus 1 equal to, so this second term is a 21, we put a 21. So we say AR 2 minus 1 is just a 1, so we just say AR power 1, or don't indicate a 1, equal to 21. So you name this as your equation 1. Okay, so from here we can also read the second information, and the fourth term is 189. Okay, so here they have given a second term and fourth term. So for fourth term you say T4 equal to AR power n minus 1. So you say AR n is the fourth term. Okay, so you say 4 minus 1 equal to this fourth term is 189. So you substitute 189. So this will give you AR 4 minus 1, it's a 3, equal to 189. So you name this as your equation 2. So the first question is calculate the first term and the common ratio. So to find the first term and the common ratio, we are going to use these two equations that we have. So what we are going to do is this. We are going to get our equation 2. This is our equation 2, which is AR power 3 is equal to 189. So and then we divide this equation 2 by equation 1. So equation 1 is AR equal to 21. So from here, you can cancel this A and this A. Okay, you cancel this R into R power 3. You remain with R power 2. So here, I will just write R power 2 equal to, so 21 here, it's a 1. 21 into 1, 89, because there are 9 times. So R power 2 is equal to 9. So this R is representing the common ratio. So we need to get rid of the square by introducing the square root to both the sides. So therefore, R equal to, so we cancel these 2 and the square root. The square root of 9 will be a positive and a negative 3. So in this case, we create the positive 3. R is equal to what? To 3. So this is our common ratio. So how do we find now the first term? So to find the first term, remember you have your equation 1 and equation 2. So you can pick any of these two. Okay, so let's say we pick this one where we say AR is equal to 21. So we know that the common ratio is a 3. So where there is R, we are just going to substitute with a what? A 3. So here we'll put a 3 right here. We are going to have A times 3 is equal to 21. So I will divide both sides by a 3 like this, so that we find the value of A. So 3 and 3 will cancel. You remain with A equal to, so 3 here, 1. 3 into 21, it's a 7. 1 into 7 will get a 7. So this is our answer. The common ratio is a 3. The first term is a 7. So we have answered our question A1. We now progress. Alright, so we now come to our question 2. Calculate the sixth term. So bear in mind that your first term, you have answered that it's a 7. And your common ratio, it's a 3, because we'll be using this. So how can we find the sixth term? So to find the sixth term, remember this is our question A2. So to find the sixth term, we are just going to say our question 2. We'll say sixth term, which is T6, is equal to AR power n minus 1. So here we need to come up with our data. So A is the first term, which is a 7. R is a 3. N in this case will be the number of the term, which is 6th term. So N is equal to what? To 6. So we are going to substitute where we say T6 is equal to, where there is A, we put a 7, okay, times, where there is R, we put a 3, when where there is N, we put a 6. So this is 6 minus 1. So this will give us T6 is equal to 7. Don't multiply this and this because this 3 is having the power right here. So 7 times 3, 6 minus 1. This will give us a 5. So remember, this is paper 2. So there's need for you to use a calculator where you punch on your calculator, you say 3 raised to the power of 5. This gives us 243. So we are going to write term 6 is equal to 7 times 243. So our term 6 is equal to, so when we punch on the calculator there, 7 times 243, this will give us 1001. So this will be our term 6. So we have answered our question A2. I hope it's clear. We can now proceed to the other question. Alright guys, so we have answered our question A2. So we now come to our question A3 right here. Calculate the sum of the first 5 terms of the progression. So how do we find the sum of the terms of a geometric progression? So take note of the common ratio. The common ratio is a 3. So there are two formulas that you can apply. Okay, if the common ratio is less than 1, or if the common ratio is greater than 1. So in this case, our common ratio is greater than 1. So here we are going to use this formula. So our formula will be sum equal to, so we are going to write A, which is the first term, open bracket, R power n minus 1, close bracket, over R minus 1. So this is the formula that you use if the common ratio is greater than what? 1. Okay, so if the common ratio is less than 1, we just interchange this. The 1 will be the first one, then R power n will be this side, the same with the denominator. Okay, so here we know that the first term A is a 7 and the common ratio is a 3. So the value of n, they are saying find the sum of the first 5 terms. So sum of first 5 terms. So this n is the number of terms. How many are they? 5. So we just now need to substitute in our formula. So we are going to say sum of 5 terms is equal to, where there is A, we will put a 7, open bracket. Where there is R, we are going to put a what? A 3, because the value of R is a 3. Then where there is N, we put a 5. So it's 3 raised to the power of what? 5. Minus 1, close bracket. So over 3 minus 1, which is R minus 1. R is a 3. Then from this stage, what you need to do is just simplify 3 to the power 5. So you are going to have sum of 5 terms is equal to 7, open bracket. So 3 raised to the power of 5, this will give us 243 minus 1 over, so 3 minus 1, it will definitely give us a what? A 2. So I hope that you are following. Then from this stage, we say sum of 5 terms is equal to 7, open bracket, 243 minus 1, this will give us 242 divided by 2. So remember, this is paper 2. So if you want, you can multiply 7 times 242. Then later on, you divide by 2. Or if this number, which is right here, if 2 is divisible into this number without leaving any remainder, you can do that. Okay, so we can say sum of 5 terms is equal to 7 times, so 2 can go into 242 without giving us a remainder. 2 into this 2, it's a 1. 2 into 4, it's a 2. 2 into this 2, it's a 1. So 2 into 242, I'll get 121. So 121 times 7. Okay, so 121 times 7, you need to get your calculator because this is paper 2. So 7 times 121. So this will give us 847. So we say therefore the sum of 5 terms is equal to 847. This is our answer. So if you don't want to divide, if it's not divisible, it's better for you to just multiply 7 times this value, then afterwards you divide by a 2. So thank you so much. We now move on to the next question. Guys, so we now come to our question 2b right here. Given that matrix P is equal to 7x, negative 2, negative x, and the 1. Question B1, find the value of x for which the determinant of P is negative 10. So they have given us the determinant of this matrix, which is a negative what? 10. So how can we answer this question? So in order for us to answer this question, we assume that we are finding the determinant of this matrix. And to find the determinant of this matrix, we can use this formula. We say determinant of matrix P is equal to, so we multiply the major diagonal elements, 7x times 1. This will give us 7x. 7x times 1 is 7x, minus negative x times negative 2. This will give us positive 2x. Okay, this is what we get. So they have told us that the determinant of this matrix, the determinant of matrix P is a negative what? 10. According to our question right here, it's a negative 10. So where there is determinant of matrix P, we just substitute with negative 10. So we have 7x minus 2x is equal to negative 10. So these are like terms. We can simplify them. 7x minus 2x, this will give us 5x equal to negative 10. So from here, we need to find the value of x. We are going to divide both sides by 5. So that this 5 and this 5 you cancel, x is equal to, so this is a negative, this is a positive, so definitely we'll get a negative value. 5 here, 1, 5 into 10, it's a 2. 1 into 2 to give us a 2. So the value of x is equal to a negative what? 10. Very important. So now, this is our answer that we have found for question B1. So let's see how we can find our question B2. Alright, so we have answered our question B1. We now come to our question B2. Hence, find the inverse of P. So here we are just told to find the inverse of matrix P. So how do we find the inverse of the matrix? So first thing, we need to know our exact matrix P, because here there is x, so we need to substitute. So we are going to do this. We know that the value of x, it's a negative 2. X is equal to negative 2. So I need to rewrite this matrix, which will be P equal to. So here, when I put a 2 on x to be like this, a negative 2, then this will be a negative 2, negative right here, and then this x we have said is a negative 2, then this 1. So this will give us something like this. We are going to have 7 times negative 2, negative 14. Then this will give us a negative 2, and the negative positive, this will give us a 2, and this is a 1. So in actual sense, this is matrix P, negative 14, negative 2, 2, and 1. Then we can come back to our question. Our question says they want us to find the inverse of this matrix P. So how do we find the inverse of matrix P? We write P inverse is equal to, so we will denote the inverse like this, is equal to 1 over the determinant of matrix P times the adjoint of matrix what? P. So we use this formula. So here we need to say P inverse equal to 1 over, so we have been given the determinant of this matrix P in the first place, which is a negative 10. Times, so how do you find the adjoint of the matrix? So to find the adjoint of the matrix, it's a very simple process. Okay, we will just interchange. We have the trailing diagonal and the major diagonal. So what we are going to do is this. This is the major diagonal element. So these major diagonal elements will interchange. So what I mean is, since here you have a negative 14 here, 1, so the 1 will be where the negative 14 is, and the negative 14 will be where the 1 is. So what happens to the trailing diagonal elements? You need to add the sign, the negative sign. So this is negative 2, it will become a positive 2 because we have added a sign negative, negative, positive. This is a positive 2 to become a negative 2 because negative times positive, it's a negative. So this is what you get. Now from here, what you are going to do is you are going to just multiply the determinant to the 1 over negative 10. So P inverse is equal to, so 1 over negative 10 times 1. This will give us our final answer where we'll get 1 over negative 10. So I'll just multiply everything, then we do the simplification later on. So 1 over negative 10 times 2 to give us 2 over negative 10. You can cross. So here 1 over negative 10 times negative 2, negative, negative, positive. So 2 over 10. Again, 1 over 2 times 1 over negative 2 times negative 14. Okay, so this again will give us negative, negative, positive. So it will give us 14 over 10. So we can write our final answer where we just say therefore P inverse is equal to, so in our final answer we are just going to simplify. This will be 1 over negative 10, 1 over negative 10 the way it is. 2 here 1, 2 into 10, it's a 5. So this will be 1 over negative 5. 2 here 1, 2 into 10, it's a 5. So it will be 1 over 5. For this one, 14 and 10, the highest common factor is it's a 2. So 2 into 14, because there are how many times? Because there are 7 times. 2 into 10, it's a 5. So this will be our answer. Okay, so this will be the inverse of matrix P. So thank you so much, everybody. We've come to the end of our mathematics session. This has been your presenter, Mr. Mlenga.